something called level 2 data. So let me explain what this really means. Now, on the stock market, right, there are two kinds of data. The ones that you see usually on mainstream media is called level 1 data. That is, it shows you the price of, say, the Apple stock that's closed at every day, right? And level 2 data is actually more detailed data that shows you how much, what are all the prices that is given by the buyers and the sellers for a certain stock at any given time. Now, using this data, our plan is to apply this algorithm known as reinforcement learning methods that would be able to make decisions by itself on when to buy, when to sell, and when to hold on to a certain stock. So this is what we have done so far. Now, in terms of the literature review, there are actually a few authors that's doing research in this field, even here in Berkeley. And the data that we have gathered is from Wharton, and it is a list of all the stock data on the NASDAQ, and it's level 2 data basically. I'll show you what exactly does it mean. So this is a particular screenshot of what you could expect. Now, this data is for Apple, and the date is on 2011 in January, and the time, right, is given at every second. So what you see here is a time at 9:30 a.m. when the stock market opened, and the list of prices you see on this side here are the prices that has been transacted between the buyers and sellers at a specific instance in time. Actually, this is level 1 data. I mixed it up, so you can see that that's the label, right? So level 2 data would be something like this. Level 2 data shows you the bid prices per second and the offer prices. Bid prices means what the buyer, what is the seller asking for, and offer is what the buyer is asking for. The bid size and offer size, these two columns, refers to the number of times each of these prices occurs. So, for example, on the top, most element for offer size, 12 would mean that the price of $382.71 is quoted 12 times. Do you have any questions at this time? It's all good, right? Okay. Now, so given that raw data, this is some of the processing we've done to clean up the data. So in order to model our algorithm, first you need to think about what are the states that we are basing our decisions on. So the states that we use is actually derived from the price data at every single second here. And these states, I'm using the mean, the variance, the skewness of the data, as well as the kurtosis of the data for each of these distributions. So let me explain what you're seeing here. Now, for this very first graph at 0th second, right, 9:30, the dots that is in red shows the bid prices at that time, and the vertical axis, well, the labels are blurred out, but the vertical axis shows you what is the volume that is traded for that specific price. So for example, at 382, right, the volume here might be about 50, as you can see here, right? So for each of these distributions, every second we calculate the mean, the variance of the data, the skewness, right, how skewed it is, and kurtosis. And I'm just showing you the data that we have prepared for just the first 6 seconds, but there's really a lot of data to crunch through, and the entire data we're using now would include 5 companies for now, which includes Apple, IBM, CVS, United Airlines, and the last one, I couldn't remember now, but I'll get back to you later on if I do. Now, this is the plot that we have shown for Apple, and the next one is United Airlines. There's some data. So I think with what you see here, right, we'll come to the key challenge of our project, right? And that is each company has a different distribution profile. In this case, Apple, as you see before, is much more heavily traded. You can see a lot more points. Whereas for other companies like United Airlines, it's not that heavily traded. So what matters, what the challenge here is to really find a portfolio, right, that actually is robust enough when we do our analysis. So I'll pass on to Royan to talk about our algorithm.
So, okay, so the way we wanted to model our data is that we wanted to apply the direct reinforced learning, which is under the category of reinforced learning. The way it works is that you specify a value function with input variable, and the algorithm will give you, will finally converge to give you the optimal parameter of the value function. So one of the important features of this direct learning is that the input variables are explicitly given. So basically, you need to identify what variable you're going to use as your states, or what variable you're going to use as your input. So this comes. So in one of our in one of the literature we refer to, they applied the direct reinforced learning to the level 1 market data. So which is generally the currency trading data and S&P 500 stock index and T-bills. So it's quite different from what we wanted to do, because we wanted to apply to the level 2 data, which is generally the distribution of the market. We kind of hope it will make sense that if we got the level 2 data, which might reflect the capacity of the market, might give us more edge to make a profitable trading strategy. So the latest news is that one of our friends, one of our team members, interviewing with hedge fund right now. He just telephoned us this morning saying one of the hedge fund in Texas are doing exactly the same strategy we're using, but they're not making a profitable trading strategy. So this could be a very promising area to look into. So okay. So generally, so our first step, our naive step, would be to find out what are the variables we wanted to use as input. Because in the literature we refer to, they use past historical returns, but it's just numbers, a series of time series of numbers. But what we want to use is a time series of distributions, which shows you the capacity of the market. So the way we wanted to modify it, we say a continuous distribution can be uniquely described by an infinite number of moments. So what we want to do is we want to find out how well the moments gonna give us a description of our distribution. So right now what we do is we select 4 important moments: mean, variance, skewness, and kurtosis. We run a least mean square algorithm because the general least mean square cannot be used because our large data set. So we use least mean square algorithm, which is a stochastic gradient descent method to do an online sample by sample algorithm to get the coefficients of the least mean square. So the results is that what we see is that I think there's more credibility in the Apple than UL and CBS, because Apple got more trading activity happen each second. What we observe is that the skewness and kurtosis carries more significant weights than the mean and variance, which are interesting because it's more related to distribution that we wanted to affect our trading strategy. So we will definitely do more tests to see if there is a consistency in the relationship between the moments and the returns. So our next step would be probably do more analysis of the moment, find out the relation between moments and the return, and improve and apply it to the trading strategy. Yes. And that's it.
Okay. Good. So thank you very much.